Okay, so in this video, okay, so I will show you on how to answer for the sample of the question on double integral for polar coordinates. Okay, so I have explained on the basic concept of double integral for polar coordinates in the previous video. So let's take a look at example 7. Okay, so evaluate the given integral where R is the region inside the circle x squared plus y squared equal to 4. Okay, so the first thing first is to get the region. Okay, to get the region first. Okay, so for example 7. Okay, for example 7. Okay, so R is the region inside the circle, right? So we have a circle here. Okay, so the equation for that circle is x squared plus y squared equal to 4. Okay, so we know that this is the general form or the general equation for a circle with the center 0, 0 and radius equal to 2. So it will be like this. Okay, so the question directly tell you that the region is inside the circle. So this will be the shaded region. Okay, so this one is 2, this one is 2. Okay, so we know that the radius for this circle is 2. Okay, so we copy the question again. So we have x squared plus y squared plus 1 dA. Okay, so since in this one, okay, the shaded region is in circular type, right? So it will be easier to solve using polar coordinates. So dA now, okay, if we change into polar, so we're gonna get RD theta. Okay, so now means that we have to figure out the limit for R and the limit for theta. Okay, so let's take a look on the limit for R first. Okay, so we know that R is from here up to here, right? So R equal to 0 to 2. So this is the limit for R. What about limit for theta here? Okay, so limit for theta here. We know that the direction for theta is anti-clockwise, right? From here, start with 0. If start here, okay, the shaded region is the whole circle, right? So means that the limit for theta is start with 0 up to 2 pi because we cover for all quadrant. Okay, so we know the limit for R and limit for theta already. Okay, so the question give you in Cartesian. So you have to change into polar first. Okay, so x squared plus y squared plus 1 is equal to R squared plus 1, right? Because x squared plus y squared is equal to R squared. Okay, so make sure that when you want to substitute the limit, so all the term should be in polar, which means that in term of R and theta. Okay, so the limit for theta is 0 up 2 pi. Okay, so the limit for R is 0 up to 2. So now this one is convert, okay, R squared plus 1. Okay, so now dA is equal to R d theta. Make sure that you do not miss this R. Okay, some of the students miss that R. Okay, so if we expand it before we solve the integration, so we're gonna get R power of 3 plus R. Okay, so now we integrate normally. Okay, so we integrate respect to R first. We're gonna get R power of 4 plus R power of 2 divided by 2. So we substitute the limits for R 0 up to 2. So don't forget to write d theta again since we still not finished for theta. So after we substitute the values, so we're gonna get 0 up to 2 pi 6 here d theta. Okay, so now we integrate respect to theta. So we got 6 theta. So we substitute the value 0 up to pi. Okay, so after that we substitute the values for the limits. So we're gonna get 12 pi. So this is the answer. Okay, so make sure that whenever you have a question, okay, whenever we have a question, get the shaded region first, and then after that you decide by your own. Either you want to use Cartesian or polar coordinates. Okay, so usually when you have circular type of shaded region, it will be easier to solve using polar coordinate instead of using Cartesian coordinates. Okay, so I hope you guys clear for example 7. Okay, so let's move for example 8. Okay, so for this question, they directly ask you to use polar coordinates. Okay, so basically in your test or in your final exam, okay, we have two types of question. Either we give you the direct instruction to use polar coordinates, or either we use we give you opportunity to decide by your own, either to use polar coordinates or Cartesian coordinates. Okay, so in this question, they directly ask you to use polar coordinates. Okay, so no matter which type of shaded region, you should use polar coordinates. Okay, so use polar coordinate to evaluate this given integral, where r is the smallest segment of the circle x squared plus y minus 1 squared equal to 1, cut off by the line y equal to x. Okay, so the first thing first is to draw the region first. Okay, so for example 8. Okay, for example 8. For example 8. Okay. Okay, so they said that in the shaded region involved with a circle x squared plus y minus 1 squared equal to 1, and then cut off by the line y equal to x, and then we only consider for what the question said again is a small segment, smaller segment. Okay, smaller segment. Make sure that you read the question carefully. Okay, so here if we would like to draw the sketching, so we're gonna get right here. Okay, so this one at y equal to 1 here. Okay, so this is the circle. Okay, for x squared plus y minus 1 squared equal to 1. Okay, and then cut off by the line y equal to x. So we know that y equal to x is somewhere here. Somewhere here, right? Y equal to x. Okay, so it cut off by this line, and then we only consider for smaller segment. Okay, so this one is the largest segment. Okay, so the smaller segment should be in this part. Okay, so in this part. Okay, so now we already know the shaded region. Okay, so the question gives to you should be like this, right? X dA. Okay, so before we substitute into the given question, we should find the limit for r and theta. Okay, so here we know that this line is equal to x squared plus y minus 1 squared equal to 1. Okay, so actually from here, okay, if you revise back on the common polar equation, this one is equal to r equal to 2 sine theta actually. Okay, 2 sine theta for this one. Okay, I did show on how to get this one right in the previous video. Okay, so for here, okay, for limit for r actually, okay, so this one is r equal to 2 sine theta. So this one, so limit for r, we know that 0 up to 2 sine theta, because start from here, right? Outward from here. Okay, so 0 up to 2 sine theta. 2 sine theta. So we are clear for the limit for r. What about for limit for theta here? Okay, so here we know that the region is start with 0, right? But up to this line only. So you should know what angle up to here. Okay, so how to get the limit for the angle for this region only? So we're gonna use this equation. So y equal to x. Okay, so no, we know that y is equal to r sine theta, and x equal to r cos theta. Okay, so from here, if we reshuffle, okay, so we're going to get sine theta divided by cos theta equal to r divided by r. So we got tangent theta equal to 1 here. Okay, so theta is equal to inverse tangent 1. So we're going to get pi over 4. Okay, so means that here the angle in that region is pi over 4. Means that the limit here is 0 up to pi over 4. Okay, so now we have figured out for both limit r and theta. So now we substitute into the original question. So limit for theta is 0 up to pi over 4. And limit for r is 0 up to 2 sine theta. And x is equal to r cos theta. So dA now is, r dr d theta. Okay, so let's rearrange back all the terms. 0 up to sine theta, we have r squared cos theta dr d theta. Okay, so now we integrate respect to r. So we're going to get r to the power of 3 divided by 3 cos theta. And then we substitute the values of r here. Okay, so from here we're going to get, if we take out the constant, okay, so we can take out the constant as 8 over 3, 0 up to pi over 4. So we have sine cubic theta cos theta here. Okay, so d theta. Okay, so now to solve this one, so we use method of substitution. So we let u equal to sine theta. So du is equal to cos theta d theta, this term. Okay, so if we modify in terms of u, so we're gonna get 0 up to pi over 4 here is u to the power of 3 du. Okay, so now it's easy to integrate, right? So we're gonna get 8 over 3 u to the power of 4 divided by 4, 0 pi over 4. Before you substitute the values of the limit, make sure that you convert back, or you substitute back the term of u. Okay, so we're gonna get 8 over 3. So u is sine 4 divided by 4, 0 to pi over 4. Okay, so after that you're gonna get, if you take out this one, so we're gonna get 8 over 12. Okay, so sine pi over 4 to the power of 4 minus with sine 0 to the power of 4 here. Okay, so sine pi over 4 is equal to 1 over square root 2. So 4, this one is 0, right? Okay, so here we're gonna get 8 over 12 time with 1 over 4, right? Okay, so if we cancel out this one, so you're gonna get 1 over 6. Okay, so this is the final answer for this question. Okay, so make sure that you get the correct shaded region, get the correct limits, and whenever you have difficulty to integrate, make sure that you revise back on whatever method that you have learned previously. Okay, method of substitution, tabular methods, okay, integration by part, or maybe use partial fraction. Okay, so I will explain on example 9 in the next video after this. Okay, thank you.